Hey everyone, so I'm going to go ahead and get started. We're now going to look at multiplying and dividing rational expressions, right? We've already covered adding and subtracting, so now we're looking at multiplying and dividing. And much like the adding and subtracting rational expressions, this is also very similar to when we multiply and divide fractions, right? So here's our first problem. My first step, right? This looks very intimidating as is, this first problem. I'm sure most of you guys are looking at this and thinking, Miss Bruno's insane. How am I going to figure this out? Well, the first step is to factor both, right? So in the adding and subtracting, we only looked to factor the denominator, but in this case, we're factoring both numerator and denominator. So do my regular factoring. If you need these steps for the factoring, make sure to look through your notes, okay? So when I factor this x squared minus 2x minus 8, I'm going to end up with an x minus 4 and an x plus 2. Now over here, I have to factor the numerator and the denominator, right? That 3x squared, there was nothing that I can do with it. It's just one term, it's a monomial, so there's no factoring involved with it. This second one, however, the first thing I'd want to do is divide everything by 2, which would leave me with an x squared minus 3x minus 10. And then from there, I want to go ahead and factor out. So it would leave me with a 2, an x minus 5, and an x plus 2. Now if we see, right, the denominator actually matches what when I factor that 2 out, the leftovers of that polynomial. So it's also going to be x minus 5 and x plus 2, right? Now, I just multiply everything, okay? So step 2 is to multiply. Now remember, just like when I multiply fractions, I multiply the numerator with the numerator and the denominator with the denominator. Meaning I'm going to end up with some crazy looking fraction, really. It's a rational expression, but we're going to look at it as a fraction of x minus 4, x plus 2, x minus 5, and x plus 2. All of that right on the top. I'm going to be able to multiply this 3x squared by the monomial 2, right, which is going to give me 6x squared times x minus 5 and x plus 2. Now, the nice thing when I'm multiplying and dividing these is this last step. So step 3 is actually to cancel common factors. Right? So whenever I have one term over itself, it always equals 1, right? So this is kind of a similar thing. So I have an x minus 5, that's going to cancel out with this x minus 5. I have one x minus 2, it's going to cancel out with that x minus 2. Meaning that my final answer, so really step 4, we're going to call it write the leftovers, is my final answer, which is 6x squared over x minus 4 times x plus 2. And I would leave it as is, okay? That is all I need to do. That is how I multiply and divide my rational expressions. And that is it for that way, okay? Now we're going to go ahead and try dividing. So in my division problem, right, let's say we have x plus 7 squared over x squared divided by x squared plus 9x plus 14 over x squared plus x minus 2. So my steps, the first one, I'm going to keep it as the same, and that is factor both numerator and denominator. So this first one here, this first expression, this x plus 7 squared would be the same thing as writing x plus 7 times x plus 7 over x squared. And that's going to be divided by, again, if you forget how to do the factoring, by all means, look through your notes. You'll find it in the Fun with Factoring section. Okay, when I factor this numerator out, it's going to give me x plus 7 and x plus 2. And the denominator is going to factor to x plus 2, x minus 1. Okay, now my step 2, right, just like when I do fractions, I'm going to, I think you guys know it as keep, change, flip, or there's copy, change, flip. The whole thing is the same thing, right? I keep the first rational expression, x plus 7 times x plus 7 divided by x squared. I change the division to multiplication, and I flip the second expression, right? So now x plus 2, x minus 1, and x plus 7, and x plus 2. Then my steps are exactly the same as before. I'm now going to multiply. So again, I multiply directly across, meaning I'm going to have an x plus 7, x plus 7, x plus 2, x minus 1, all over x squared, x plus 7, x plus 2. And again, my last step is still to cancel the common factors. Oh no, this isn't my last step. My last step was to write the leftovers. So in this situation, I have in common an x plus 7 and an x plus 2, right? Now I'm going to write the leftovers. Which is just going to be x plus 1, or x plus 7, x minus 1 over x squared. And that is my final answer. So I think that multiplying and dividing is much easier for us. It is basically one thing that you're really doing, which is multiplying and then canceling out common factors. I think that's a bit easier than having to multiply by the least common denominator and all that stuff. So this video is a little shorter than adding and subtracting, but the material is still the same. Okay. For your practice problems to do that are going to be due at the end of class, you're going to solve. The first one is going to be x over x minus 9 times 3x plus 27 over x plus 1. And the second problem, which is going to be a division problem, is going to be x plus 11 over 4x divided by 2x plus 6 over x squared plus 2x minus 3. Okay, so those are your two problems that are going to be due at the end of the class.